So this week, we are going to kind of go back and review code first with EntityFramework, and we're going to be creating the MVC music store. And then we're going to be kind of moving forward and adding sorting, filtering, and pagination to Contasso, along with adding a view model for grouping data. And as usual, the hands-on sections in the lecture walk you through portions of your assignment. And there are videos embedded throughout. Let me refresh this. So each video kind of explains what's going on. And then there are files that you can open and copy and paste code from. The only code that I don't have you copy and paste is the code that is new, the things that we're learning. As far as what you need to turn in, make sure everything is on GitHub. And we're going to be creating the controllers and views, generating those using code first for MVC Music Store. But before you add that to GitHub, you need to decide if you're going to want to sort on multiple columns, add a search box and pagination to the music store or to your final project. Also for the music store, you have the option of doing a little extra credit, which involves branding the about, contact, and index home views and the layout view. So basically you're going to make them look nice and you're going to get rid of that generic MVC code. And that's worth 10 points extra credit. So before you turn in the music store, decide if you're going to want to add the sorting and the searching and the pagination, all of that to the music store, or if you want to do it to your final project, and decide if you want to do the extra credit, because you should only turn in one music store file. Okay. Then for Contasso, all of the hands-on that we do as part of the lecture demo will have that completed, and you need to add that to GitHub as well. And then you're going to be giving me links to the music store repo and to the Contasso repo. And if you choose to add the sorting, searching, pagination, try catch to your final project, I need a link to that repo as well. If you run into problems or if you have questions, make sure you have it up on GitHub so I can download it and take a look. You can also come into my office for office hours or get help during lab in class, or we can maybe arrange a time to meet on Zoom. Lots of different options. Then we have a little discussion. This hopefully will be kind of fun for you guys because we go in here and I want you to think about your everyday life. We are impacted by code every single day. So I want you to give an example of something that was coded well and something that was coded poorly. And for something that was coded poorly, what could you do to improve it? You know, and for something that was coded well, you know, how did interacting with that make you feel? And is there any way that you think that could be improved? And then I want you to kind of review each other's posts and reply to at least 3. Okay, so, and I'll give you guys an example, something that I think is coded poorly would be the stoplights in Traverse City. They don't adjust for rush hour or for summer traffic, and quite often they don't stay yellow very long. It's like it flashes yellow and then it turns to red right away. So I think that code could be improved, and it makes me frustrated having to deal with it. And then for Oh, quality code. I can actually think of quite a few things that I use every day that are coded well. But the one that I actually like is my Fitbit app. And I log all of my food that I eat, and it breaks it down into proteins and carbs and fat and all that kind of stuff. Is there anything that could be improved? Uh, yeah, they could probably do a little bit more with nutritional analysis, break it down to vitamins and all that kind of stuff. So anyway, those would be two examples that I have, and I'm sure you guys have lots of examples of your own. So again, we have the assignment, we have the discussion this week, and if you run into problems or if you have questions, let me know.